Hello and welcome to Permutations Part 1. Now to start off, I'm just going to refresh your memory as to what we have seen with the fundamental counting principle. We had 3 cards and we wanted to know how many arrangements were possible, and we found we could do that by going 3 times 2 times 1. And that gives us the number of arrangements. Now order mattered in this, okay? So order matters. And we're not allowed to repeat any of the cards. Once you used the A card, that was it. You couldn't use it again. So there was no repetition sneaking in here. So no repeats in this, at least in the card example here. And this is what we call a permutation. Okay? So in other words, when you have a situation and the order that you make your arrangement matters, and you're not, once something's used, you're not using it a second time, then that is what we call a permutation. All right? Now there is a much faster way to calculate these kinds of numbers where they go down by 1 each time. Let me just show you the shorthand way of writing that. Okay, this means exactly the same thing as 3 times 2 times 1. Now this is read or called 3 factorial. So this little symbol here is called a factorial. Okay, it is not an exclamation mark. It does not mean 3 said out loud or something. It means 3 factorial, and it means 3 times 2 times 1. Now while we're at it, 1 factorial, for definition, is 1, because that's kind of the end of the road. And if you ever see a 0 factorial, that's also 1. Okay? You don't keep going into the negatives, in other words. Just like I've shown here, with 3 factorial, that means 3 times 2 times 1, and that's where it stops. What it does is it really makes a much faster way of calculating bigger numbers. So let me just show you an example here. So we're going to clear the screen. Suppose we had 8 people in a lineup. Okay, 8 people in a line. And you were wondering, hey, I wonder how many different ways I could arrange these 8 people. Like maybe they're up at the front of the class and they're going to take a bow or something. Wonder how many different ways there are. Well, fundamental counting says that for the first spot, there would be 8 choices. Second spot, there would be 7, and then 6, and so on. Okay, that can get a little tedious. This one's still reasonable on a calculator, but it would be a little tedious. Much quicker if you just said, hey, isn't that 8 factorial? And what you want to do is find the factorial button on your calculator, because then you just go 8 factorial, hit enter, and you've got your answer. And there it is. Just a tip, a lot of the factorials are hidden under a menu of math, so you got to press a math button usually, and then have a little look. Sometimes it's tucked under probability. If you have to look under math and probability, you'll probably find the factorial symbol in there. Okay, now I'm going to do another example. I'm going to clear off the screen here because I'm going to build off this example and build a formula. What if we weren't going to use all of the elements in the set? In the previous example, we used all 8 people and lined them up. But what if, say we had 20 people, or 20 students in the class, and we were going to choose, say, the first student is going to be the class president. Okay? Class president. Maybe the second one chosen is the class vice president, and the third one could be treasurer or something like that. Okay? So in other words, the order that I pick these 3 people does matter because they have jobs associated with the order they were picked in. But really what I want to do is I want to take 20 of people and I want to pick 3. So I'm not using all 20. So I can't just say it's 20 factorial. Now if I was using, and then of course the question is how many groups of 3 are possible? How many such groups are possible. Groups of 3 are possible. Well, fundamental counting is a pretty easy way to do it. I could just say, well, for the first person to choose the class president, I would have 20 choices, right? Because there's 20 people to choose from. Then I follow that with, okay, how many are left from which I'm going to choose vice president? Well, there'd be 19 left to choose from. And similarly, once those 2 have been chosen, there are 18 left to choose a treasurer from. So that gives me my answer, no problem, using good old fundamental counting. But I'm going to show you how I can develop a formula that's very calculator friendly from this. Okay, so here's what I'm going to do. I'm going to take that same expression, okay, 20 times 19 times 18, and I'm going to do the following to it. I'm allowed to do it because I'm going to divide by the same thing. I'm going to multiply that by 17 times 16 all the way down till I get to 1. But I'm going to do the same thing on the bottom. So see, I can get away with this because I'm multiplying the top by this mess, and the bottom I'm dividing by the same mess. So this is in fact just, this is the number 1, right? This is the number 1 because you got the same thing on top as you have on the bottom. Now why would I do this, you might say? Well, look at what you now have on top. I got 20 times 19 times 18 times 17 times 16 all the way down to 1, which is 20 factorial. Hey, look at that. And on the bottom, I have 17 times 16 all the way down to 1, which is 17 factorial. Okay, so now, instead of using a fundamental counting, I could be using these factorials, but I'm going to go one step further. I'm going to leave the top as 20 factorial, and on the bottom, instead of writing 17, I'm going to write that as 20 minus 3 factorial. Now you might say, hey, you're just really overcomplicating things. Possibly, but let me show you why this form here is really quite useful. Because take a look at the numbers that are involved in this. There's a 20. In my question, I had 20. Okay, so I have a 20 here and I have a 20 here. And then there's this other number, there's a 3. Oh, yeah, I have to pick 3. So, you know, I'm using the same 20 and the same 3 that are in the question, and I've plugged them into this kind of formula here. Well, your calculator has a way of writing that, and it looks like this. It says 20, pick 3, and this actually means the same thing as this very example. There are 20 uniquely different things to choose from. We're going to pick 3 of them, and the order matters. So 20, pick 3. And if you look on your calculator, you will see there is a button for that, and it will spit out the answer if you plug it in. Let me see, what is the answer here? Oh yeah, we already have the answer, 6,840. Anyway, this is the fast way to get to that, I guess is what I'm saying, or an alternative way. You know, there's nothing wrong with your fundamental counting, but this is another way to get there, and sometimes much easier depending on the question. Let me just summarize that formula for you, and then that's where we're going to stop. What we have seen is this. If you have n items, so this is n different items, okay, or people, or whatever it happens to be, and you wish to pick r of them, r items, okay, and again, very important, order matters here, okay. If you have A, B, C, that's considered different from B, A, C, etc. So order matters. So here's what we have. We have a formula, n pick r, and it works like this. On the top is n factorial, and on the bottom it's n minus r factorial. Okay, and that's how you deal with these kinds of questions. All right, that's where I'm going to stop for now.